The project was about looking at chill accumulation in stone fruit and apples. We didn't include the apples though because the block did get pulled out, so we ended up doing it in cherries and almonds, and looking at increasing the chill accumulation over the winter so we could accumulate more chill during a warmer winter. Yeah, the calcium carbonate product we use, which gives a white colour to the tree. So we applied it in May when all the leaves were gone off the trees. The idea was that white colour reflects the heat and the light over the winter, so it actually accumulates more cold or more chill. We had a good effect, or good result in almonds, where there was about a 4 or 5 day difference between the treated and the untreated areas. But almonds being low chill, so they only need 23 chill portions or so around there, that accumulated pretty quickly, and then because the trees were still cooler, it delayed the trees and kept that chill accumulating. In cherries we didn't find that result so much, because being a high chill variety or a high chill type of fruit, that they accumulated enough chill anyway. By especially August last year we had a lot of frost, so accumulated quite a lot of chill late in the season, so we didn't get that difference, so there wasn't really much to see in the cherries so much. The end result was a similar yield, similar crop timing and everything, so there was no downside to it, no negative to it. Because the more we know about chill and the more we look at chill, is the less we actually understand the accumulation. Because I think there's two important parts, and one is the cold and the chill accumulation, which we often talk about, especially with climate change and that coming through. But the other is the heat component after the chill's been accumulated. So when the trees have accumulated enough chill to break dormancy and then go into that growth phase, how warm that heat area is really important to how the trees perform, which we found in the almonds. I think the chill accumulated quickly, but it was still cold after the chill accumulation was there, so the trees didn't get away to that early start, which if it had been a lot warmer, which we expected and the forecast was for that period, but it was still quite cool, and we're looking at a similar thing this year and actually over the last few years. Probably one thing that came through from what got me interested in this project was during the drought in 2010, around that area, we accumulated half the amount of chill that the stone fruit trees would normally accumulate. But we had no effect on flowering. Flowering was normal time, flowering was similar, crop load was similar, so if we're talking at that time it was hours below 7. Canning fruit varieties were something like 1,000, 1,100 hours. When we were getting 600-700 hours, there was no difference on the flowering or the fruit set there. So some other things come into play, and probably going through this project there's a lot of other things that come into play with this. So chill accumulation is one part. The heat after that chill is a major factor. Trouble is, it's a lot more difficult to actually do something about. I think there's some dormancy breakers. This calcium carbonate actually helps, that sort of thing, to accumulate more chill. But to warm up the tree after that chill accumulation's been reached is a lot more difficult, and that's certainly an area I'd like to look at and see what we can do in that area. I'd like to thank Glenn Riseborough from Cherry Hill Orchards for allowing us to do the trial with the cherries, and Abby White from Almonds at Robinvale with doing the work in the almonds.